As I was introduced, I work at ANZx, and I work on a team called the Enablement team, which focuses on like a wide variety of different things. But one of the things that we're quite interested in is architecture. And like with anything, we want to be able to test what we're doing so that there's no manual work involved. And that's what I'm going to be talking about today. So architecture testing for Android. And we're going to start really at the basics and ask the question, what is architecture? So Wikipedia defines architecture as the abstract structure of a software system. So those of us on Android are probably quite familiar with acronyms that we use to describe our architecture: MVVM, MVP. There are any iOS devs out there. I'm sure they've seen a few Vipers in their time. And we might also see this abstract structure described in diagrams, something like UML, or even just less formal diagrams that help explain the abstract structure of our software systems. But this architecture, these acronyms and diagrams, are basically underpinned by rules. These rules define the types of components in our system, and these rules define the relationship between our components in the system. Sometimes these rules are written down. When we talk about those UML diagrams, it's quite a formal way of describing some of these components and their relationships. Or sometimes these rules can be inferred. For example, if you told me that you had an MVVM architecture in your project, there are some certain rules and components and understanding that I can infer from that acronym. Applying these rules is what conforms a project to an architecture. And inversely, if you don't apply these rules to a project, you end up not conforming to the architecture and slowly drifting away. And we have architecture for a reason, all sorts of reasons, right? We want our code to be consistent, easily maintainable. We do especially want to avoid drifting away into an unmaintainable chaos project, right? So if it's important to follow these rules and conform to them, how do we enforce that we are conforming to them? Well, in just about every project I've worked on, where this has started and stopped is asking people nicely. So I write some code, I open a pull request, you read my code, and you say, oh, hey, you've called this a context factory manager, but actually I think this should be a factory provider, or this doesn't follow this rule, or I think this code could be improved to better fit the rules in some way. And that works reasonably well, right? Like I said, many of the projects I've worked on, this is where it has started and stopped for enforcement of architectural rules. But this has problems. It's slow, right? I have to, or you have to, manually walk through the changes that I have made line by line and check that they conform to these rules. It's easy to miss things as a reviewer. We are only human. We can't remember all of the rules in our heads all at the same time. And you can just, accidentally scroll too fast and miss something important and fail to help that pull request conform to the rules. And also, rules that are written down, especially the ones that are a little bit more inferred, they're easy to argue about, which just makes things even more slow. For example, a rule that's got some fuzziness or grayness around the edges, you could get into big discussions about really what is the correct way to apply that rule. So, can we do better? Well, it would be a very boring talk if I said, no, we have reached that, that is the best we can do. And so, of course, I'm going to say, yes, we can do better. and we can do better with architecture testing. So, what is architecture testing? Well, it's a way of taking those rules that we're talking about that underpin our architecture and apply some kind of automated verification that those rules are being followed. It also serves as a concrete, strict definition of what those rules are and how they should apply. In some ways, architecture testing is similar to linting. I'm sure most of you will be familiar with linting, being a static analysis of your code that can tell you about formatting and naming, all sorts of things like that. Well, linting is true static analysis. It doesn't run your program to, detect the issues with your code. Architecture testing is not quite the same. It doesn't run at program runtime in production or anything like that, but it runs at test time. So your code is actually running and is therefore inspectable using reflection. So rather than dealing with abstract syntax trees and PSI elements and all of those complex APIs that can make up linting tools, you get to use something that's a little more sort of natural to the language, Kotlin, Java, those reflection APIs. And architecture testing runs inside of like existing test frameworks as opposed to running as an external tool. So at ANZ Plus, we use ArchUnit for our architecture testing, which is what I would like to talk to you about today and give you a little bit of an insight into how that works and how you might go about getting started with ArchUnit. ArchUnit describes itself as a library for checking the architecture of your Java code using any plain Java unit testing framework. So from that description, it's a Java library, which might raise some flags for us. Works with any testing framework, which is good. I'm sure most of us are using some variation of JUnit, those of us who are Android developers. But one of the things I really like about ArchUnit is that it has quite a readable and understandable API. So really helps make these tests serve as documentation, not just tests. So as I mentioned, this is a Java library. So how well does ArchUnit work in a Kotlin-based Android project? The answer is pretty well. Despite the fact that ArchUnit was designed for testing like back-end projects and not apps and not Kotlin, the interoperability APIs that Kotlin has with Java and the way that ArchUnit is set up makes it pretty easy to do good interoperability. So the way that we're going to answer this question, hopefully, is dive into a little bit of code and understand basically the structure of ArchUnit and how you would go about writing some tests yourself. So if we dive in, we are going to imagine we have this JUnit test class called example architecture tests. And we're going to write a rule today that is going to verify some simple rules about the view models in our project. Now, before we actually get to writing the body of our test, there's an important first step that we need to take. We tell ArchUnit to import some classes. So we grab ArchUnit's class file importer and we tell it which packages we're interested in. For example, if you have a package, your package here, you're probably not interested in importing all of the internal Android packages and verifying their architecture. You could if you wanted to, but I would advise against it. There's some additional filtering here that you can do, but we might talk about that a little bit more later. All you need to know is this is essentially a big list of all of the classes in your project. From there, we can go and actually look at the test. So we're going to look at a test that is going to verify that if we have a class that extends the AndroidX view model class, so a view model for a screen, we're going to verify that that class should be named viewModel, should have a suffix with viewModel, right? So that test looks like this. We start off by creating an Arch rule definition. So we create a rule that says classes that are assignable to viewModel should have a simple name ending with viewModel, and then verify that against classes. And really, that is as simple as it gets. You can see that this quite readable DSL is almost exactly, before we even began writing the test, the kind of test and the kind of rule that we wanted to create and verify. We can get a little bit more complicated here. So for example, while this rule is good, we probably also want to verify almost the inverse of it, right? If you have a class that has a name ending with viewModel, you probably also should expect that to be assignable to the viewModel class too. So we can use Boolean operators like ORs and ANDs to add more context and more information to our tests. So here we can say that classes that are assignable to viewModel or have a simple name ending with viewModel should have a simple name ending with viewModel and should be assignable to viewModel. And if we run this test in a project that is designed to have a failure for this test, we would get an output like this as the unit test fails. And you can see that this output we're getting is itself actually really useful. It's going to tell us the entire rule in like an English readable way. It's just sentences telling us what the rule is. It's going to tell us about the violations that it's found in our project. And it's going to tell us for each of those violations, why was the violation triggered? So we can see real list presenter there doesn't have a simple name ending with viewModel. So we can tell that real list presenter must extend the viewModel class. And what I really like about this kind of the rules and the output that you get out of this is that you can do almost test-driven development of your architecture. So you're joining a new project, instead of needing to front load yourself and with like all of the information about all of the rules, or worry about opening pull requests and getting heaps and heaps of feedback, you can just start writing code. And if you write code that is wrong, the tests are going to guide you and tell you what did you do wrong and what might you or what should you have done instead. It's quite a nice way to work. All right, so really this simple Arch rule definition is basically all you need to know to start writing valuable tests. Like, it doesn't get too much more complicated than this. But what I would really like to do is sort of have a little bit more of a deeper look about what makes up an architecture test in ArchUnit. So we're going to look at an alternative way that we could write the same test. So we take our test here, classes that are assignable to viewModel or have a simple name ending with viewModel, and we look at the structure of this. And we can see that there are two main parts. We select and then we assert. Quite straightforward. It's almost a like trimming down of the arrange, act, assert pattern that is quite common in unit testing. So we have our selection and our assertion. What can we select and assert on? Well, we can select classes, constructors, methods, fields. ArchUnit also loads relationships between classes. So we can select classes that are related to each other in some way. And additionally, we can select anything that is describable from a class through reflection. On the other hand, we can assert on names, annotations, packages, return types, access to and from other objects. And again, anything that is describable through reflection. And it is this describable through reflection thing that I would like to sort of point out and look at as we look to rewrite or look at an alternative way of writing that viewModel test. So to write this test, with a sort of more complex syntax, more generic syntax that doesn't quite follow that DSL approach, we can start off by creating what is called a described predicate. And a predicate is just essentially a function that takes an input and returns true or false. And a described predicate is a predicate that has a description. So we can see here that the description of this might be a view model. And in the predicate, we get past a Java class, and we do essentially what we were doing in the previous example. We check if the class's name ends with view model, or if the class is assignable to view model. And you can guess what's going to come next. We're going to describe another predicate as a valid view model, which is almost exactly the same in terms of the code that we use. The name ending with is assignable, but we use an and instead of an or. Now, these on their own are not architecture tests, but we can create an Arch rule definition and say classes that might be a view model should be a valid view model. Then check against the classes that we're loading. So essentially, you can see how that nice English readable syntax that we were using before, with those sort of more verbose selections and things, really under the hood, all it is doing is a fancy wrapper on top of this concept of a described predicate. And it's important to understand how described predicates work and where they fit in. For example, if I was going to write this test, I probably would actually personally choose to use the more expressive DSL. However, if I understand how a described predicate works, I can extend that DSL, and extending that DSL for things that are project specific or Kotlin specific can be quite powerful to do. So I want to also take a look at how we might assert some Kotlin language concepts using described predicates, something that ArchUnit doesn't do out of the box. Now, that's actually pretty simple. So we're going to have a described predicate. We're going to describe classes that have companion objects. And quite simply, we get passed in a Java class, which is ArchUnit's representation of a class. We call reflect on it, which gives us the Java language reflection class object. And we can just use the Kotlin interop there to get the K class. From there, we can just check if any of the nested classes within that K class are companion objects. Same thing, we can, we're not limited to just describing classes. Here we can describe a method, describe whether or not a particular function is suspended. Again, we do pretty much the same thing. We just drop into some Kotlin reflection, and we can assert whether or not that is a suspending function or not. And just like before, it's pretty easy to put those two things together into a rule. We can say that methods that are declared in classes that have companion objects should be suspended. Now, I don't know why you would want to write that rule. It's quite a bizarre rule to have, but it's a good example of how you can use ArchUnit to assert these Kotlin concepts that it actually doesn't really know anything about. So the point that I want to sort of like drill home about the point that I want to drill home about how ArchUnit works and how architecture tests should be sort of thought about is that we want to find all T, some kind of object that match some predicate, and then verify that they also match another predicate. And if you just take that one thing away, that is all you need to know about how to write effective architecture tests. But what else is there, or what can we test using that sort of basic structure? Well, all sorts of useful things. View models shouldn't depend directly on network APIs and make API calls from that layer. You want to indirect through a repository or something like that. You can verify that your repository functions are suspending and are operating in background threads. There's all sorts of useful things that you can use to or test with these sorts of rules. Now, what else is there to learn about ArchUnit? Like, what haven't I talked about? So there is something called a freezing rule, which is quite useful for introducing ArchUnit into a large project that probably already has a few violations in it. It's essentially like baselining, lint baselining. So you run the freezing rule, it gives you a list of the violations, and then it will fail for new violations, but it will allow the previous violations to sort of continue on. There are these, what ArchUnit calls layer or onion architecture tests, which are essentially just syntactic sugar on top of what we've just been looking at, which, if you ask me, is already pretty syntactically sweet. But these tests are essentially common things where you, instead of defining classes or objects, you define layers within an architecture, and then there are some common sort of rules that you can apply about dependencies between layers if you're following clean architecture or like a onion-based plugin model or anything like that. But really, there's not that much else. If you can read the Arch rule definitions and write described predicates, that is the toolbox that is going to let you test almost anything you need to in your project. So that's a pretty good overview to begin with, and is hopefully enough for you to go away and get started with some of this stuff. But what I'd really like to talk about as well is, hopefully, if you are interested in this, what have we learned from using ArchUnit over the last year or so at ANZ Plus? So the first thing is, and again, I'm trying to make you get away and write some of these tests yourself. The cost to start this is very low, right? So you probably, or hopefully, you have unit tests already. This is just another unit test. Your unit tests are already running in CI. You're not going to have to create, new CI steps or configure tooling that runs on your CI runner images like you might need to with linting or things like that. So there's a lot of complexity that you just don't need to worry about. There's no Gradle plugins to add. It is just one line like dependency to add this library to your test file, to your tests, and then you can start writing tests. And even really simple tests can provide quite valuable, because what you might find is that your code is probably a lot less consistent than you thought it is or thought it was. So you write some code, everybody in your team writes some code, and that is 100% consistent with the architecture that you have today. And then 2 months later, your architecture is subtly changed, or the best practices are just slightly different, but you and your team continue to write code that is 100% consistent with that. And that process goes on and on. The rules slowly, slightly evolve, and you feel like you are always writing consistent code that is, applies the architectural rules correctly. But it's only when you look back at that older code that you realize that actually it's not really consistent with the rules that we have today. And what I found writing some of these architecture tests is that there's actually probably more of that code than you might suspect, where you run these tests and it's going to give you visibility and failures on things that you didn't really know were a problem, which is super valuable in my opinion. Additionally, I mentioned when we were importing those classes, I said you could import a package and there's additional filtering that you can do. Just like the rest of ArchUnit, you can use described predicates to do this and filter out some classes that are not interested, that you are not interested in when you're doing testing. And this is quite important to do. So for example, the IDE, if you're using Compose, generates like a bunch of these like live literal static classes and things, which can often violate rules but they're not really real code. They're like the live little update things. You want to just filter those out and ignore them. If you're using Dagger or Hilt or any other code generation in your library, in your application, sorry, you probably also want to filter that out. It's going to just, get rid of hundreds of classes that don't need to be verified. So what I would say is when you start writing some tests, make sure that you are putting some thought into what classes you actually want to verify these rules on. Now, on the previous slide, I just told you about freezing rules and how they were great for big projects. In my opinion, I don't actually like freezing rules, and we don't use freezing rules at ANZ+. So we use a different approach where we have, for each architecture test in the code, there is a matching annotation called an architecture exception annotation. So for our view model example that we had there, you might have an architecture exception for view model is not named correctly. And what you would do with that is, in addition to the test that we wrote that checks all those names, we just ignore any classes that have that annotation on them. So instead of having this like frozen baseline massive XML or JSON file that lives somewhere in the code base and occasionally gets updated or whatever, it's very difficult to review on pull requests. When you want to violate a rule, break a rule for a reason, you have to add that annotation to that piece of code, and it really helps highlight these things in code review, as well as making it really easy to report on and understand the different hotspots of these architectural violations of the code. Structure also brings clear rules. This sort of select and assert pattern backed by reflection helps kind of change the way that you might think about and describe your architectural rules. So, for example, talking about things like, business logic should live at this layer. Well, in an architecture test, you can't really, it's kind of hard. What is business logic? So instead of trying to enforce this vague thing where you say that, well, business logic should live in this layer and have arguments on a PR about, is this really business logic? Does this count as business logic? You kind of start to think in a slightly different way and look at, of all the code that we think is business logic, what are the common, like actual concrete properties of that code that we could assert on and talk about and write rules for? Additionally, what you want to do is try and find like some synergy between rules. Instead of writing one massive rule that's going to verify the whole architecture of your entire project, try writing a few smaller individual rules that on their own might not be so valuable, but kind of combine together to create like a nice structure and description of your project's architecture. All right. And that is basically everything I have to talk about today. What I have here is a link to the ArchUnit website if you want to check that out. I have an example project on GitHub, which has just got like a markdown file with some rules in it and some sample code that breaks a bunch of those rules on purpose so that you can write some tests yourselves and try and test out ArchUnit. And then also on the bottom there, I have a thing where I just say, spent half an hour talking about ArchUnit. If you're interested in doing architecture testing and you're doing that brand new, you might want to also check out Consist. It's pretty new. The library's only been out for like a couple of months, but it is a Kotlin inspired, or Kotlin library inspired by ArchUnit. Haven't had a chance to play around with it myself yet, but it's worth mentioning. All right, thank you very much.
Questions? Oh, keep up here.
That's pretty good. Should be hard stuff. Yeah, exactly. Like a little.
Fine.
Let's do it next time.
Does ArchUnit play nicely with RoboElectric?
What do you mean by with RoboElectric?
Well, I guess, have you encountered any, I'm not fully across the details about how you integrate this into a test yet, so I might be missing something obvious, but have you encountered any integration issues where it can involve roboelectric in a test or anything like that, or you've got on your class bar that cause issues?
No, I haven't encountered any of those issues myself. It's worth noting that like these tests don't need to run as roboelectric tests, but where they live in our code base at least, there are also some tests that use roboelectric that live next to them, and there's no compatibility issues if we run them all together. And, you know, the roboelectric tests work and the ArchUnit tests also work. And
cool. Also, can you make assertions about method bodies? So, for example, if you wanted to verify that the view model wasn't interacting with your API layer, how could you stop it from doing so if it was making a call inside a view model function body somewhere and it was just like the bytecode was doing it?
yeah,
It wasn't really much of a trace elsewhere.
so because it works on reflection, there are things that you can assert about method bodies and there are things that you can't. So relationships to other objects, like calls other objects and things like that, you can absolutely verify that. What you can't use ArchUnit for is any formatting based stuff, because it is operating on the bytecode and like fully through reflection. So like if you want to verify that your view model doesn't access APIs directly, or particular methods don't do that, that's absolutely something that you can verify with ArchUnit.
Cool, thanks.
In terms of lessons learned, what about the process side of things, especially on large projects? We often have multiple teams. Who's writing these tests? Who's fixing them when they break? Who's looking after them?
That is a great question. We've got quite a big team. I think, I don't want to quote numbers and get them wrong, but we've got a lot of teams. The way that we do this is we've got a working group called the Architectural Working Group. We meet twice a week for an hour, chat about architectural problems and solutions and all that sort of thing. And it's sort of that group that maintains these rules and really writes new ones and, you know, maintains them. If there are architecture decisions being made, we often have some documentation that goes along with that, like we call them ADRs, Architecture Decision Record. We write big things, these are the options we chose, blah, 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 blah. Send that out to the team feedback, the team gives us feedback, cool. And then, you know, once we've made a decision and we have some documentation saying this is how it works, we can write a test that sort of like matches that documentation. Does that answer your question?
Yes, thank you.
Any other questions? I think we've got time for one more.
So usually like we are competing with resources, I mean, to integrate all those testing. Where do you think this ArchUnit comes in priority with other testing we already have in the project?
So in terms of priority, you mean where you spend your time writing them?
Yeah.
I mean, I don't think these are necessarily the highest priority tests that you can write. You know, they're not going to solve bugs for your user. They're useful to have over the long term, particularly if you have a project that you want to live for a while and you want that consistency and you want to ensure code quality over time. But, you know, on your day-to-day life, writing these tests, you're probably actually not going to write that many of them. I think in our project, we have maybe 30 or 40 of these individual tests. And that's honestly all we need to verify actually quite a lot of different things. So really, when you think about 30 or 40 tests in terms of the effort that it takes to write those compared to, you know, you might write 30 or 40 tests to test one view model and the functionality of how that works. So my answer is not super high priority, but also don't need to write that many.